Mini hydroelectric plants, often referred to as small hydro, have emerged as a vital component in the transition to renewable energy. These compact systems generate electricity by harnessing the power of flowing water, providing a clean, efficient, and environmentally friendly alternative to fossil fuels. Mini hydroelectric plants are particularly valuable for rural or remote communities, offering sustainable energy solutions where larger infrastructure might not be feasible. In this video, we will explore the types, components, benefits, challenges, and comparisons of mini hydroelectric plants with other renewable energy sources, alongside examples of innovative projects demonstrating their potential. Mini hydroelectric plants generally have comparable efficiency to traditional large-scale hydroelectric plants, with both types capable of achieving high conversion efficiencies, often exceeding 90%. These mini hydro plants typically refer to hydropower installations with less than 10 megawatts of capacity. However, definitions can vary by country and organization. Mini hydropower systems, usually ranging from 100 kilowatts to 1 megawatt, typically have a lower capacity factor of about 48% compared to 57% for conventional hydropower technologies. This means that mini hydro plants may produce less electricity than their maximum capacity over time. These mini systems can be more adaptable and easier to install in various locations, including small rivers, streams, or existing water infrastructure. This flexibility allows for power generation in remote or rural areas where large-scale plants are not feasible. They often use run-of-river schemes or existing water infrastructure, minimizing disruption to ecosystems and wildlife. Both mini and traditional hydropower plants offer flexibility in adjusting output to meet demand fluctuations. However, smaller systems may have quicker response times due to their reduced scale. Mini hydro systems can be more cost-effective for remote or developing areas due to lower investment costs and the ability to utilize local resources. While efficiency in terms of energy conversion may be similar, mini hydroelectric plants offer unique advantages in terms of environmental impact, adaptability, and accessibility for smaller-scale applications. Mini hydroelectric plants offer several environmental benefits but face challenges in their construction and implementation. Mini hydro dams produce clean, renewable energy by harnessing the power of flowing water, helping to reduce greenhouse gas emissions and mitigate climate change impacts. Unlike large dams, mini hydro plants typically don't require water reservoirs, which can release chemicals and negatively impact the surrounding ecology. Mini hydro plants can decrease reliance on fossil fuels, particularly in remote or rural areas, by providing a reliable source of renewable energy. Implementing mini hydro projects can raise awareness about proper watershed management and reforestation, promoting sustainable water resource use. Main challenges in building mini hydroelectric plants include finding appropriate locations, which is a significant challenge. Mini hydro plants require specific site characteristics, including sufficient water flow, vertical drop, and accessibility. While generally less expensive than large-scale plants, mini hydro projects still involve considerable upfront costs, which can be a barrier, especially for smaller communities or developing areas. The construction and maintenance of mini hydro plants require specialized knowledge and skills, which may be scarce in remote or rural areas. Navigating the permitting process and complying with environmental regulations can be complex and time-consuming. Inadequate water flow during dry seasons can impact power generation, making consistent output a challenge in some locations. Lack of proper monitoring, inconsistent maintenance, and absence of appropriate equipment guidelines can lead to mechanical failures and reduced power output. While less impactful than large dams, mini hydro projects still need to consider potential effects on local ecosystems and implement measures to protect aquatic life. Despite these challenges, mini hydroelectric plants remain a promising source of clean, renewable energy, particularly for remote or underserved areas. With proper planning, community engagement, and technological advancements, many of these obstacles can be overcome, allowing for more widespread adoption of this sustainable energy solution. When comparing mini hydroelectric plants to solar and wind energy in terms of cost and efficiency, several factors come into play. Mini hydroelectric plants are highly efficient, with modern hydro turbines capable of converting over 90% of water's energy into electricity. Solar panels typically convert 19%, to 21% of sunlight into power, with some advanced panels reaching over 23% efficiency. Wind turbines can harness about 50% of the energy that passes through them, making them more efficient than solar panels but less efficient than hydropower. Mini hydro plants often have lower upfront capital costs compared to other renewables, but transmission infrastructure can be expensive. Operation and maintenance costs can be higher due to complex turbine mechanics. Solar requires significant initial investments, but has minimal ongoing fuel costs and lower maintenance expenses. The cost of solar has been decreasing due to technological advancements. Wind power costs have decreased significantly in recent years, making it increasingly competitive with fossil fuels. However, wind farms typically require large-scale installations to be economically viable. Hydropower offers more consistent and predictable energy generation compared to solar and wind, which are dependent on weather conditions. Solar generally has the lowest environmental impact, while hydropower can disrupt local ecosystems. Wind power's impact varies, but can affect wildlife and create noise pollution. Solar panels are more easily scalable and can be installed in urban areas, while mini hydro and wind farms are often limited by geographical constraints. While mini hydroelectric plants offer high efficiency and reliability, solar and wind energy have seen significant cost reductions and technological improvements. The choice between these renewable sources often depends on local conditions, available resources, and specific project requirements. Here are 5 unique examples of mini hydroelectric plants that offer sustainable energy solutions. 1. Vortex turbines. ResearchGate, DesignBoom, and CurrySpower have illustrated vortex turbines for micro-hydro applications here. These nature-inspired turbines feature a plug-and-play installation for easy setup. Fewer moving parts, which reduces maintenance needs. Minimal ecological impact with no disturbance to river flow. Suitability for small canals and streams. Ideal for rural communities with unreliable power sources. 2. Whirlpool Turbines by Turbulent is a Belgian startup that has created resilient and cost-efficient whirlpool turbines for small rivers or check dams. Some of its key features include low-pressure operation requiring only a 5-foot height difference, fish-friendly design that allows aquatic life to pass through unharmed, easy installation and maintenance, remote control and monitoring capabilities, environmentally friendly power generation for remote communities. 3. Kinetic NRG is an Australian startup that offers a lightweight power generation solution called the Micro Hydropower Kit. This system includes an environmentally friendly rotor for efficient power production from low-velocity water flow, modular design with transportable structures, integrated power module (IPM) for grid-ready electricity, smart power management system for AC electricity balancing, suitability for remote and private locations. 4. Blade Runner Energy is a Dutch startup that has developed a scalable micro-hydro technology that harnesses energy from natural water flow without the need for dams. Some of its features include a proprietary rotor design inspired by natural water motion for improved efficiency, a flexible power takeoff configuration, above-water housing for generator and power electronics, reducing costs and improving reliability, focus on energy equality, and sustainable power generation. 5. IBECA Project's community-engaged approach. While this is not a specific technology, the IBECA project demonstrates an innovative approach to small hydropower implementation. This project focuses on overcoming challenges through community engagement, providing sustainable electricity to rural and remote areas, emphasizing local involvement and ownership in hydropower development. These unique mini hydroelectric plants showcase the potential for sustainable, localized energy production that can benefit remote communities while minimizing environmental impact. In conclusion, mini hydroelectric plants are a cornerstone in the global shift towards sustainable energy. Their high efficiency, adaptability, and minimal environmental impact make them an ideal solution for powering remote and underserved areas. While challenges such as initial costs and site suitability exist, innovative technologies and community engagement have the potential to overcome many of these obstacles. As the demand for renewable energy grows, mini hydroelectric systems are poised to play an increasingly significant role in creating a cleaner, greener future. If you enjoyed this video, hit that like button, comment, and subscribe. Check out some of my other videos before you go. Thanks for watching. We'll see you on the next one.